Hello! Today we are going to be working on the Skills Integration Challenge that is built into the Cisco Networking Academy Routing and Switching Essentials course in Chapter 7. And to make it a little bit easier to navigate through, I have prepared a worksheet with the instructions and the addressing table so that we can be as efficient as possible. I have also replicated the network topology diagram along with some useful labels to call out the interface identifications. You will find if you open the PacketTracer that there might be some misnomer information. I believe over here in the branch, when you use the pop-ups, that both interfaces may be identified as G01, and that can get rather confusing, and for that reason I have created this diagram for you so that you can see where the G00 and G01 interfaces actually are. So that should be of help to you. So let's begin by looking at the scenario and some of the initial requirements. So you're going to finish an addressing scheme. So there's some review for you in recalling and bringing back all of the learning that you've absorbed thus far on creating a subnet from a given network root and subnet. Then you are going to configure a little bit of static and routing protocol configuration, and finally work a little bit with access control lists, which is the main topic in the current chapter. So let's begin by looking at requirement number 1A, dividing the 172.16.128.0/19 into two equal subnets for use on branch. So that is the branch router. And then we're going to assign the last usable address, read carefully, to the second subnet of its G00 interface, and then assign the last usable address of the first subnet to the G0/1 interface. We'll document that addressing in the addressing table above, and then configure branch with the appropriate addressing. So because this is an assignment for you, I'm not going to show every single step. So there may be some, jumping ahead throughout this tutorial or walkthrough, but I definitely want to give you the foundation and framework for all the major steps so that no one gets completely stumped as they go through this assignment. So, starting at the beginning, let's divide that 172.16.128.0 address into its two equal parts for use on branch. So when we come up with a requirement like this one, I like to explain it to students in a very granular fashion, really very, step by step, so that those that have difficulty can follow along. So let's start with that 172 and 16. I'm just merely going to carry that down because we're not going to be working with borrowing any bits in those first two octets, so I'll just leave them in their dotted decimal format. Then in the third and fourth octets, I'm actually going to represent those in their binary form. So 128 is just, a 1 bit in the 128 position, and then 64, 32, 16, 8, 4, 2, and 1, which is just 2 raised to those powers, would be just represented as 1 followed by 7 zeros. And then the last octet we have as 8 zeros. Very good. So now we need to divide into 2 equal subnets by borrowing a bit position. Okay. So I'm going to move that imaginary line that was at the /19 over 1 position. And that way I will make a 0 subnet, and then we'll have a 1 subnet to follow. So you see, we now have 2 equal subnets for use on branch. So the additional requirement that will be necessary is to understand what the broadcast address will be, and then the last usable address in each of these subnets. So the broadcast address, of course, would be found by flipping all of the bits to 1. So that would end up by creating a address of 172.16.143.255, and you can work that out in your mind by flipping these last 4 bits to 1 in this third octet. And don't forget that you have a 128. So 128 plus 8 plus 4 plus 2 plus 1 will give us the 143. And then all 1 bits in the last octet will be 255. So that's going to be our broadcast address for this subnet. And then, of course, the mask is going to be a /20, right, because we borrowed an additional bit, and thus the last usable address is going to be 254, and you can use various means, either a web search or work it out for yourself to figure out the dotted decimal formation for a /20 as far as the net mask, and a /20 is equal to 255.255.240.0 for the net mask. Okay. Now in the second subnet, we would use the exact same technique to find the broadcast address for that subnet, and then subsequently we would also have that same net mask because we would also be in a /20 domain or realm. So we would come up with 172.16.159.254 in a /20 for the last usable address in that subnet with the same net mask. So let's take a look at the chart that we need to populate. And we were told in our instructions that we needed to use the last usable address from the second subnet on the G00 interface. So that would mean the 172.16.159.254, and we just calculated that that subnet mask was 255.255.240.0. And then you'll know what to fill in for the G01. It was that address that we calculated as the last usable address in the first subnet. So we documented the addressing table, and now we need to configure branch with that appropriate addressing. So we can open up the branch, go to the command line on that router. We know that we have to use the enable command to get into the privileged exec mode and config T for global configuration. And now we can configure the interfaces. So we would go to the interface of the G00 interface, put in that IP address for the address that we just populated into our table, which was the last usable address in the subnet. We need the network mask. And of course, we have to issue no shutdown to bring up that interface. Do not forget to also configure the G01 interface of the branch router as well. Now we will move to step B, where we are going to configure device B1, which is a PC, with the appropriate addressing using the first available address of the network to which it is attached, documenting that addressing in the addressing table above. So B1 is attached to the G. It's actually, this is where I said there was a glitch, because we're looking at the PacketTracer topology, and when I hovered over this interface, it makes it look like it's the G01 interface, but in fact, let's go back to the worksheet where I documented it as correctly being G00. How did I know that? Well, you know, both of these show up as G01, so I knew that couldn't be true, right? They can't both be the same interface. So how do I determine which correctly is that interface? Well, I looked at the switch over here in the PacketTracer, and I could see that VLAN 1 in the switch had an address of 172.16.159.253 in that /20 subnet. So I concluded that the addressing used for that switch was then related to the G00 interface subnet that we just recently calculated. So this is the G00 subnet, and so now B1, according to our instructions, needs to be configured with the first available address in that subnet. So I will go and choose that first available address in that subnet of 172.16.144.1, and of course the /20 is still represented by a subnet mask of 255.255.240.0, and we will have a default gateway of the router interface, which leads us to the outside world. So if I am at PCBC1 and I'm reaching out to find how to get to the outside world, I would get not to the G01, because that is wrong. It will be the G00 interface of that branch router, and so that interface is 172.16.159.254. So that is the default gateway for the device B1, the PCB B1. So let's go into B1, go to its desktop and IP configuration, and we know that that PC is supposed to be configured with the address 172.16.144.1. The subnet mask is not in its class full address mask, so we have to change to the 255.255.240.0, and the default gateway is the IP address of the G00 interface on our branch router. The DNS server was already populated, so we will trust that that is correct and be complete with that step. Now we have made our way to part C, where we are going to configure a routing protocol, RIP version 2, on both the HQ and branch routers. And we're going to use some specific criteria. We're going to advertise the networks, 3 attached networks. We are not going to advertise the link to the internet, and we are also going to configure appropriate interfaces as passive. Okay, passive interfaces are typically connected to what they call stub networks. Stub networks are like the one we see here to the far left and up above, because they don't go anywhere. They're LANs that are dead ends, basically. So they typically, once the equipment is attached, there's no new network information coming from faraway locations to be repopulated, so they're somewhat stable and static, and that is why we configure a passive interface in those cases. So again, we're going to advertise 3 networks. We are not going to advertise the network to the internet, and we are going to configure appropriate interfaces as passive. I will work on the headquarters router and then leave the branch router to you. So first we must issue the enable command, and of course go into configuration mode. And at this point we are going to want the RIP protocol, and we need to specifically say version 2 of the RIP protocol. And then which networks do we want to advertise? We want to advertise, it says all 3 networks. The network attached to the LAN above HQ, to the left of HQ, and then the serial link to the right. So that is the network command, and we will advertise 172.16.0.0, because one thing you remember when you talk about advertising networks with RIP, you use the class full network representation. So 172 is in the class B range, so we will advertise the network in this way. We will not advertise the 192.168, and it's 0.0. So we will complete the address specification for the network along the serial link. We do not want to advertise the network connected to the internet, so we will not mention the 64 network. We want to tell RIP not to use auto summarization. And then we also want to specify the passive interfaces. So the passive interfaces are going to be this network to the internet that we just mentioned. So that's the serial 0/0/0 1, and we have a passive interface also to our 172.16.0.0/18 network, which will be our G01 interface. And we also want the G00 interface to be a passive interface as well. You will need to configure the branch router appropriately to complete the requirements in this lab. Now, at step D, we want to set a default route back on HQ, which will direct traffic to the S0/0/1 interface. That would be over that pathway, and then redistribute the network to the routing protocol. Okay. So back on HQ, we need to first, if you are still in the router config mode, we need to exit and put in an IP route of quad 0, a space, and the net mask is also a quad 0 mask, meaning everything that, it's like the default route. If you don't find a match in the routing table for your destination IP, this is called a route of last resort, and the route of last resort is, we are told, is the serial 001 interface. Okay. We do not have to be highly concerned about the warning message that we have been given. It's merely just that, a warning. But now we need to redistribute, so we need to go back into the router RIP prompt and issue the default information space originate command to redistribute that routing information. It is now time to do some packet filtering using access control lists. So we are asked to design a named access list. The name is branch server, to prevent any computers attached to the G00 interface of the headquarters router from accessing the branch server. So we haven't specifically been told whether to use a standard or extended ACL, but I'm going to tell you that you are going to use a named standard ACL. That is what this particular PacketTracer assignment grades on. So let us refer to some information that I placed in Moodle. It's a worksheet that's entitled ACL Syntax and Overview, and there is a section on naming standard ACLs, access control lists. So the one takeaway is that by naming an access control list, you have a little bit more usability, readability, understandability, because now you're not talking about ACL 10 or 20, which is, virtually meaningless. You can refer to the access list by some meaningful name. So, step 1 is to start from global configuration mode and use the IP access list command to create the named ACL. And we have already been given an alphanumeric name to use. We will use that name, branch server. Then we will use some permit or deny statements to specify what it is we want to achieve. And then we will return to the privilege exec mode and then place that access list or define it on a particular interface. And you can refer to this document for some additional details on access control lists. But I will start by looking at the branch router, and from the config prompt, I will put in IP access list standard and then the name that we have been given, branch server. What is it that we want to do on this particular filtering operation? We want to deny access from a particular subnet and it turns out that it is 172.16.64.0, and now it's not a network mask, it is something called the wildcard mask, which you should have studied during your chapter reading. Also, there are some write-up in this same worksheet about wildcard masking and how zeros represent matching of bits and ones represent the ignoring of bits. It's like the flip side of a net mask, and thus you can convince yourself why 0.0.63.255 would be the correct designation. Also remember, all access lists must have at least one permit statement, or everything will be denied, because all access lists implicitly have as their last statement a deny all. Okay, so if we've already denied and then the implicit statement denies all, we're never going to get any traffic through. So we will put a permit any, and then basically we are now finished with the naming of, or the definition of, our named ACL. Now we need to apply that ACL to an interface. What interface do we want to apply that to? Well, the guideline is with a standard ACL, you want to apply it as close to the destination as possible. So we are looking at a destination of branch server, so we would want to apply this to the gig 01 interface on our branch. So interface G01, and we use the IP access group command with the name. And what is the direction that we want to apply it? We want to apply it to outgoing packets, so the direction is out. You will need to do a similar function on the HQ router. You will use the same methodology. And once you have that access list information configured on both the branch routers and the HQ router, you will have completed this PacketTracer assignment. You will be able to look at your skills integration challenge activity, see that your completion shows 60 of 60. You can look at the checked results in the assessment items and look at all those beautiful green check marks and be able to upload your PacketTracer assignment for a grade, hopefully a perfect grade. So thank you for following along, and I hope this was extremely helpful for you. See you next time.